All the functioning of this basic-looking box depends on the interaction between electric current, a copper coil, and a simple plastic membrane. The current and coil cause the membrane to vibrate. The membrane pushes and pulls the surrounding air. Essentially, it pounds waves into the air, sound waves. By controlling the electric current that moves this small plastic lining, the speaker can make any sound imaginable. Let's look at how it works. In the enclosure are two speakers, one for low sounds and one for highs. Both have the exact same parts and work the exact same way. A permanent magnet, a diaphragm, just a plastic membrane. Stuck to the membrane, a copper coil. The coil is inserted into the magnet. When the current circulates through the copper coil, it creates an electromagnetic force that pushes on the coil. By changing the direction of the electric current in the coil, we change the direction of that force. So, the coil is pushed one way when the electric current circulates in one direction, and the opposite way when the current changes direction. Since the coil is attached to the diaphragm, where one goes, the other goes too. This interaction is the key to understanding how a speaker works. All of this happens in a fraction of a second, because the current changes direction very quickly, up to 26,000 back and forth times a second. How often the direction of the current changes depends on the sounds the speaker is required to make. Low notes will get the current to move back and forth about 40 times in 1 second. That means the diaphragm will vibrate 40 times in 1 second. The faster the current changes direction, the faster the diaphragm vibrates and the higher the sound coming out of the speaker. A small electric circuit in the speaker enclosure directs traffic, sending the proper electrical signals to the proper speaker. Low sounds go to the bigger, low-frequency speaker, while high sounds go to the high-frequency speaker. So, it's by controlling the speed of the changes in direction of the current that we control how low or high the sound coming out will be. Simple, efficient, and cool.